Hello guys, and welcome back to my YouTube channel. Today we have an Olympiad Math challenge. The question is, if 3 to the power of a minus 2 to the power of a equal to 65, what value of a satisfies the equation? Now this is an equation that looks kind of odd, but we will try to do justice to the question. Okay, so what we're going to do is to try to modify the left hand side so that the equation becomes solvable. Okay, now there is something I'm going to do. First, I'm going to raise the power of 3. You know, the power of 3 is, this one is 3 to the power of a. So I'm going to modify it by saying 3 to the power of a all raised to the power of 2 over 2. Of course, we know that 2 divided by 2 is still the same thing as 1. And then this goes back to 3 to the power of a. So whatever I do here, I must also do to this term. 2 to the power of a all to the power of 2 divided by 2 all equal to 65. Now I want you to look at this. If we know that a to the power of m over n is the same thing as a to the power of 1 over n dot m. This is very important. So I'm going to rewrite the powers now as 3 to the power of a all raised to the power of 1 over 2 dot 2 minus 2 to the power of a all raised to the power 1 over 2 dot 2 equal to 65. This is 65 place. Okay, so from here, this can further be written as a to the power of 1 over m dot m is equal to a to the power of 1 over m, 1 over n all to the power of m. And then I come back here and then rewrite this to give 3 to the power of a dot 1 over 2 all raised to the power of 2 minus 2 to the power of a dot 1 over 2 all raised to the power of 2 equal to 65. And I continue from here. To say this now becomes 3 raised to power a over 2 all to the power of 2 minus 2 raised to power a over 2 all to the power of 2 equal to 65. So from here now I can say let p equal 3 raised to the power of a over 2 and q equals 3 raised to the power of 2 raised to the power of a over 2. So once we establish this, I can go on to say that from here this becomes a difference of 2 squares. So then this becomes p squared minus q squared equal to 65. And we know from algebra that x squared minus y squared is the same thing as x plus y bracket x minus y. And so I'm going to rewrite this to give me p plus q times p minus q equal to 65. Now we are going to make some very important assumptions here. These are very important assumptions that we need to make. Number one, we need to make it clear that before we go to our assumptions, mathematical assumptions now, we need to first of all find the factors of 65. We know that 65 can be written as 1 times 65, can also be written as 65 times 1, and then of course we can have it as 5 times 13, and also as 13 times 5. All these are possible factors. Okay, now before I proceed, we need to also make this assumption that from what we have it that 3, these are what we have, 3 to the power of a over 2, and then 2 to the power of a over 2. We need to assume, it's not an assumption, it's a fact that has to be established, that 3, the base, is a prime number, or prime factor. Prime number or prime factor. Let's put it that way. Same thing applicable to the 2. It is a prime factor. And therefore, the two factors we are going for must be prime factors or prime numbers. Therefore, as a result of this rule, these will not be accepted because both 1 and 65 are not prime numbers, and they are also not prime factors. And the same thing goes for 65 and 1. Now what about 5 and 13, and then 13 and 5? We also have to note that for this, we have to establish the fact that P, from what we have here, P is greater than Q, and Q is in turn greater than 0. And therefore, this implies that P is, of course, greater. P and Q cannot be 0. P cannot be 0, and Q cannot be 0. Now, if that is the case, and this will mean that P plus Q must be greater than P minus Q. And for that simple fact, we are going to say that, again, that because this is so, P cannot be 0, neither is Q going to be 0. And based on that fact, we are going to rule out this third option. So we are left with the last option, which means that P plus Q times P minus Q will be equal to 13 times 5. So from here now we are going to form a system of two linear equations. So we have P plus Q will be equal to 13, we call this equation 1, and then P minus Q will be equal to 5, we call that equation 2. Now we need to add up the two equations. Let's say if we add them up, so that will give us P plus P, that will give us 2P equal to P plus minus Q, that will give us 0, then 13 plus 5 will simply give us 18. And then from here, P will be equals to 18 over 2, and then P equals to 9. Now, having obtained the value of P to be 9, we can go ahead and obtain the value of Q. So, from equation 1, we know that P plus Q equal to 13. P is 9. 9 plus Q equal to 13. And then Q will give us 13 minus 9. That gives us 4. Therefore, this implies, therefore, we can say that PQ equal to 9 and 4. Okay, so what we are going to do now is to go back to the question where we say recall that 3 to the power of a over 2 equals to P, and then 2 to the power of a over 2 equal to Q. And what are the values of P? P and Q. P is 9, so 3 to the power of a over 2 equal to 9, and then 3 to the power of a over 2 equals to 3 to the power of 2. So since we have base to be equal on both sides, that is, if you have a to the power of x equal to a to the power of y, and because you have base to be equal, then this implies that x equal to y. Okay, so we apply this to both sides, and then the bases will cancel out. And so what we have now is a over 2 equal to 2. And then if we cross multiply or multiply both sides by 2, you have a over 2 dot 2 equal to 2 dot 2. So a will be equal to 4. We do the same thing to this. Since q equal to 4, we say that 2 to the power of a over 2 equal to q equal to 4, yes. And that will be 2 to the power of a over 2 equal to 2 to the power of 2. Bases on both sides will cancel. Equal bases on both sides will cancel. You have a over 2 equal to 2. And then a over 2 dot 2 equal to 2 dot 2. So we have a to be equal to 4 in both cases. So if you look at it very critically, you will see that at the end of the day, a equal to 4. Now what we need to do is to test. Let's test or check. You can check it or test it. We have 3 to the power of, originally we have 3 to the power of a minus 2 to the power of a equal to 65. 3 to the power of 4 minus 2 to the power of 4 equals to 65. And then of course this is 81 minus 16 is equals to 65. And then this is 65 equal to 65. This is correct. So guys, thank you for dropping by. Please, if you are visiting my channel for the first time, I'd like for you to subscribe to my channel and give this video a like. Thank you. I see you in the next video.